Hello viewers, friction question 3. A body has a mass of 200 kilograms and rests on a ramp with an angle of 22 degrees to the horizontal. If the coefficient of friction between the ramp and the body is 0.1, determine a few things. So let's start by drawing a diagram of the situation, and we have a ramp which is 22 degrees to the horizontal. We have a 200 kilogram object on it, and let's draw our free body diagram. So we have a weight force, mass times gravity. We have a normal force which is perpendicular, and we also have a friction force. Now if it's going to move, it's going to slide down the incline, which means that we need friction to be pointing up the incline because friction acts against motion. So if we draw a vectored triangle out of what we've got mass times gravity, we've got a normal force N, and we've got a friction force which is going to complete the triangle, and we have a 90-degree angle there. So that is the force due to friction, and which angle makes a 22 angle? Now, which one's the 22-degree angle? That will be, in this case, the angle with the vertical. Okay, so first thing we need to find is the normal force, Fn or N, which is going to be, if we use trigonometry on that triangle, we get mg multiplied by, we're looking for the adjacent side here, so it's cosine since mg is the hypotenuse, and m is 200, g is 9.81, cosine of 22 degrees. Calculating that gives us 1,819 newtons. Part B, we need to work out the force due to friction. So the force due to friction is mu multiplied by Fn, which is, mu is going to be here, mu equals 0.1. Force due to friction we've found to be 1,819. Calculating that gives us 181.9 newtons. Now we need to find the self-weight force, which is the component of weight parallel to the incline. Okay, so the component perpendicular to the incline was the normal force, but the component parallel to the incline will be the self-weight force. Self-weight is mass times gravity multiplied by, we're now dealing with the opposite side, which is sine theta, is the mass is 200 times g is 9.81 sine of 22, and if we calculate that we get 735 newtons. Question D, does the object slide? If so, what is the acceleration? So if the object is not sliding, then the 200 kilogram body is in equilibrium, which means that it's not going to move, and the forces that are perpendicular to the incline balance out, as do the ones that are parallel to the incline. The forces that are parallel to the incline are the force due to friction acting up the incline and the self-weight acting down the incline. So if those are equal to each other, then it will be in equilibrium, and of course the force due to friction really is a maximum force. So if the self-weight is smaller, then friction can match what the self-weight force is. However, the frictional force can only go as high as 181.9 newtons, and if the self-weight force is larger than that, then we will no longer have equilibrium. Then the self-weight force will be larger and the object would slide. We already know what the self-weight and friction is. Self-weight is, we've found to be 735. Force due to friction is 181.9. So the self-weight is greater than the force due to friction, therefore the object will slide. And now we need to work out the acceleration. So we can use Newton's second law for that. Mass times acceleration equals forces. Let's take down the incline to be positive. So that's going to be forces down the incline minus forces going up the incline. So forces going down the incline, that's the south weight, which is 735 newtons, minus forces going up the incline, which would be friction. So since the object is now sliding, it's in motion, and we need to use the kinetic coefficient of friction, which we're given here to be 0.08. So we get 0.08 multiplied by the normal force for friction. So that's 0.08 times the normal force is 1,819. And if we calculate that, we get a... If we calculate that we get a force due to kinetic friction, which is 735 minus this part works out to be 145.52, and that's the mass times the acceleration. Acceleration is therefore going to be 735 minus 145.52, and we're dividing by the mass of the object, which is 200, and that gives us 2.95 meters per second squared. Okay, so we've got part D. We know it's going to slide down the incline with an acceleration of 2.95 meters per second squared. There is one last part to the question. Repeat the analysis if the angle and the mass are kept the same, but the coefficient of friction is changed to mu s equals 0.5. Okay, so the normal force is, as we worked out before, mg times cosine of the angle. Now that does not depend on the coefficient of friction. There is no mu there, which means that's going to be unchanged. Normal force is still going to be 1,819 newtons. Now the force due to friction, which is of course mu times that normal force, now we're using a coefficient of friction of 0.5 multiplied by 1,819, and that gives us 910 newtons. The south weight, recall, was mg times sine theta. Again, that does not depend on the coefficient of friction, so that's going to be the same as it was earlier, which is 735 newtons. And now we've got friction. Force due to friction is greater than the south weight, which means the object will not slide. Okay, thanks for watching. Over and out.